My Safety Training Online presents Concrete and Masonry Safety for the Construction Industry 2014. Welcome. What topics will be discussed? Well, thank you for asking. What OSHA laws will apply to you in concrete and masonry safety? Where the safety hazards are. How best to protect the worker from hazards. We'll define terminology applicable to this field, talk about precast concrete hazards, and lift slab concrete hazards. Chapter 1 will discuss OSHA laws. Chapter 2 will discuss the definitions applicable to the field. Chapter 3 will talk about the types of concretes and the hazards involved, along with the general safety requirements of Chapter 4. Chapter 5 will document concrete hazards again. And on Chapter 6, we'll talk about the equipment and its safety precautions. Let's get started. Chapter 1, OSHA laws that apply to concrete and masonry safety. The general requirements of concrete and masonry safety are detailed in 1926.701. Equipment and tools are talked about in .702. And cast-in-place concrete regulations are talked about in .703. Lift slab operations are talked about in .705. Masonry construction in .706. Chapter 2, OSHA concrete and masonry definitions. Formwork. Formwork is a system of support for freshly poured or partially cured concrete. Limited access zone. This is an area next to the masonry wall under construction that is established to limit the access of employees. Precast concrete. This is concrete sections that have been cast and stressed prior to being set. Shore. This is a supporting member that resists comprehensive force imposed by a load. Cast-in-place concrete. Formwork that must be designed, fabricated, erected, supported, braced, and maintained so that it will be capable of supporting without failure all vertical loads. Precast concrete uses slip forms, scaffolds or work platforms required for slip forms. Design must be adequate, and the safe rating of lifting must not be exceeded. What is the safety factor? Well, the safety factor for tilt-up inserts is a 2-to-1 safety factor. Precast inserts have a 4-to-1 safety factor, and all lifting hardware must have a 5-to-1 safety factor. Lift slab definitions. These must be planned by a professional engineer with only essential employees allowed to work in the area. The jacks must be marked with their rated capacity, and they must have a 2.5-to-1 safety factors. All jacks must have a safety device in the case of failure. General safety discussion, Chapter 3. We'll talk about concrete and masonry issues which we haven't discussed so far. No loads are to be placed under a concrete structure unless they are capable of supporting the load. All protruding rebar must be guarded to prevent impalement from occurring, and there is absolutely no riding on concrete buckets. Concrete mixers with a capacity greater than 1 cubic yard must have a mechanical device to clear skip of material. Guardrails should be on each side of the skip, and compressed air hoses on the concrete hose pumping system, must have fail-safe connectors. Limited access zones. These are established prior to the start of work for all work on walls over 8 feet. Walls 8 feet or less do not have to have an established zone if adequately braced. Access is restricted to those employees constructing the wall. Qualified persons only can inspect the form prior to the movement. A tagline is required on the form. No one other than the rigger on the top of the form after a rollout. Fall protection requires it to be anchored to the structure for the rigger involved. No one is permitted on the form during movement. The safety line attached to the form must be attached to the form during a rollout procedure. Workplace hazards of concrete and masonry safety. Chipping, hammering, and drilling of rock are some of the causes of silicosis, along with crushing, loading, hauling, and dumping of rock. Abrasive blasting using silica sand are also contributory factors in silicosis hazards. Abrasive blasting of concrete, regardless of the abrasive used, is a contributory hazard to silicosis hazards. Sawing, hammering, drilling, grinding, and chipping are also potential hazards, along with demolition of concrete and masonry structures. Remember, dry sweeping or pressurized air blowing of concrete, rock, or sand dust will also produce high concentrations. Dry sweeping or pressurized air blowing of concrete, rock, and sand dust are serious causes of disease. Even materials containing small amounts of crystalline silica may be hazardous if they are used in ways that produce high dust concentrations. When workers inhale crystalline silica, the lung tissue reacts by developing fibrotic nodules and scarring around the trapped silica particles. This fibrotic condition is called silicosis. For respirable dust containing crystalline silica for the concrete industry is measured in millions of particles per cubic foot, or MPPCF. MCCF stands for millions of particles per cubic feet. To find out what your exposure is, contact an industrial hygienist. The American Conference of Industrial Hygienists can find one in your area. Go to acgih.org to find one in your area. Drilling of concrete pavement containing crystalline silica during interstate repair is a potential silicosis hazard. When a new highway construction site opens, a concrete pavement will be sawed to provide expansion joints for the concrete. 2 workers operated commercial type pavement saws and 1 operated a water truck. The water truck provided water for the blades of the 2 saws, which used a gravity feed. Respirable quartz was not detected in any of the samples, even though the bulk dust samples indicated the concrete samples contained 18, 19, 21, 22, and 24% quartz. Efforts to prevent silicosis may be inadequate if any of the 5 following happen at a job site. There is a lack of awareness about the sources of silica exposure, the nature of the silicosis, and the causes of the disease. Number 2, the failure to substitute abrasive blasting materials that are less toxic than those containing silica. Number 3, there are inadequate engineering controls and work practices. Number 4, inadequate respiratory protection programs for the workers involved in the project. Number 5, there is a failure to conduct adequate surveillance programs, including exposure and medical monitoring procedures. Section 5. Concrete silicosis situations. A 39-year-old man was diagnosed with silicosis, which is progressive massive fibrosis, and tuberculosis after working 22 years as a sandblaster. He had noticed a gradual increase in the shortness of breath, wheezing, and discomfort from minimal exertion. A tissue was taken from his lungs showed extensive fibrosis. The sandblaster was first diagnosed with silicosis when a worker also developed tuberculosis. State Health Department had administered a chest x-ray and skin testing to his entire crew. He was one of 20 workers who sandblasted welds during a water tank construction project to prepare the metal for painting. While sandblasting, he wore a charcoal filter respirator. During 10 to 11-hour days, he spent 6 hours sandblasting. 2 of his brothers and 3 nephews worked with him, all tested positive for tuberculosis. Case number 2. Case number 2 is a white male non-smoker who was diagnosed with advanced silicosis, emphysema, and asthma at age 49 after working 23 years as a tile installer. His work included polishing and drilling tile where he was exposed to grout dust. He did not use a respirator. Information about dust controls at the time was not available. He was exposed intermittently to sandblasting, but he did not do any sandblasting. Section 6. Job site recommendations for controlling hazards. Figure 1. We'll talk about abrasive blasting of concrete containing crystalline silica. Silica sand is the abrasive. The National Institute for Occupational Safety and Health recommends the following measures to reduce exposures to respirable crystalline silica in the workplace. Number 1. Recognize when silica dust may be generated and plan ahead to eliminate or control the dust at the source. Awareness and planning are the keys to prevention of silicosis. Number 3. Do not use silica sand or other substances containing more than 1% crystalline silica as an abrasive blasting material. Use engineering controls and containment methods such as blast cleaning machines, cabinets, wet drilling. Number 5. Do wet sawing of silica-containing materials to control the hazard and protect adjacent workers from the exposures. Number 6 of job site recommendations calls for routinely maintaining dust control systems to keep them in good working order. Number 7. Practice good personal hygiene to avoid unnecessary exposure to worksite contaminants such as lead. Number 8 of job site recommendations calls for wearing disposable or washable protective clothing at the worksite. Showering, number 9, if possible, and change into clean clothes before leaving the worksite to prevent contamination of other areas. Number 10 of job site recommendations calls for conducting air monitoring to measure worker exposure and ensure that controls are providing adequate protection for workers. Number 11, use adequate respiratory protections when source controls cannot keep the silica exposures below the National Institute of Occupational Safety and Health permissible exposure limits. Provide periodic medical examinations for all workers who may be exposed to respirable crystalline silica. Post warning signs to mark the boundaries of work areas contaminated by respirable crystalline silica. Concrete and masonry safety summary. The key to preventing silicosis is to keep the dust out of the air. Dust controls can be as simple as a water hose to wet the dust before it becomes airborne. Number 1, use dust collection systems available for many types of dust generating equipment, putting the emphasis on engineering rather than personal protective equipment. When purchasing equipment, look for dust controls. Use local exhaust ventilation to prevent dust from being released into the air. Always use the dust control system and keep it well maintained. Do not use the equipment if the dust control system is not working properly. During rock drilling, use water through the drill stem to reduce the amount of dust in the air, or use a drill with a dust collection system. Use drills that have positive pressure cabs with air conditioning and filtered air supply to isolate the driller from the dust. When sawing concrete or masonry, use saws that provide water to the blade. In summary, using good work practices such as the ones we have suggested minimize exposures and prevent nearby workers from being exposed. For example, removing dust from equipment with a water hose rather than compressed air. Using vacuums with high efficiency particulate air filters or HEPA filters. Using wet sweeping instead of dry sweeping. Using abrasives containing less than 1% crystalline silica during abrasive blasting prevents quartz dust from being released into the air. Using containment methods such as blast cleaning machines and cabinets to prevent the dust from being released into the air. Thanks a lot for listening, and we appreciate you being here.